To achieve international climate goals, aviation needs to develop technologies to drastically reduce the emission of greenhouse gases by 2050. Hybrid electric propulsion is one of the pillars underpinning sustainable aviation. Bringing electric propulsion on board significantly increases the electrical power levels of aircraft. This creates both thermal and electromagnetic challenges. EASIA, a European Horizon 2020 project, has developed technology enablers that can tackle these challenges. EASIA has come up with solutions for the thermal challenges by designing low-weight and volume-efficient power feeders, as well as two-phase cooling systems that handle the increased heat dissipation. Without electromagnetic compatibility mitigation, interference generated by the powertrain increases the risk of disturbing other on-board equipment. The EASIA consortium has developed solutions for power electronics, filtering, and power UWIS that mitigate the increased electromagnetic emissions. EASIA has focused on solutions that are scalable to hybrid electric regional aircraft.
Some of these solutions come together in a demonstrated test involving the powertrain of Sportstar Epos, a two-seater electric aircraft from eVector. Here in the EMC facilities of NLR in the Netherlands, we have built up the prototype powertrain of eVector's aircraft, integrated with power feeders from GK and Fokker Elmo. This powertrain includes the batteries, the inverter, and the electric motor, which is mechanically loaded by a dynamometer. The batteries in this powertrain form the source of electrical power for this powertrain. This power will be delivered by DC cabling to the inverter, which will convert the DC currents and voltages into three-phase AC currents and voltages. On the other side of the inverter, an AC cable designed by Fokker Elmo will then deliver this electrical power to the electric motor, which, when installed on the Epos aircraft, will drive the propellers. Under operational conditions, we will measure the conducted emissions at various positions in the powertrain, as well as the radiated emissions from the power feeders.
As a Dutch company manufacturing cable harnesses for aircraft, we have been collaborating with NLR in development of power feeders for electrical propulsion. One of the main targets we applied for was optimization in terms of weight, while still complying with EMC and thermal regulations. We selected the most promising concept and put it now to the test of the Epos demonstrator. The results will serve for further verification and validation of the power feeder solutions we developed, and it also will bring us background knowledge which we will use for development of future power feeder design for electrical aircraft that are scalable to all aircraft sizes.
So far we have developed our small, fully electric aircraft Sportstar Epos. There is still a long way to introduce it into the market, and one thing that you need is to properly address EMC problems that this kind of aircraft can have. The demonstrators that we are now testing in our facilities will help us to find out where we are with respect to EMC performance on the Epos powertrain, and also it will provide us knowledge how we can improve our designs in future.
The EASIA project has resulted in thermal and electromagnetic solutions to safely handle the higher power levels required for hybrid electric flight, thereby contributing to the safe introduction of electric powertrains on board aircraft of various sizes, enabling sustainable aerospace.